Hello, everyone. I hope you all are safe and well. Excuse me. My name is Danesh-Mand, and it's my pleasure delivering this short presentation to you today. As you're probably aware, to further support the students undertaking the subject of Advanced Project Risk Management 15317, a number of additional online training material have been developed. These short targeted presentations will help you to better identify and understand the key aspects of this topic for further studies. However, I would like to highlight that this material should be only used as a supplementary, not as a replacement for the full training documents and references provided for this subject. Please refer to the university's course online platform or contact your lecturer to access and discuss full set of training material for this subject. Okay, so on that basis, let's start our session today, which is for a case study related to the quantitative risk analysis. If you recall, in previous session, we had another example of QRA, but for the people that they haven't attended the other session, I will go through some sort of initial briefing before we share the case study too. The other sessions are also available online, and you can refer to them as you need. Just before that, a quick disclaimer that I need to say that all the views and discussions and experiences that I'm sharing with you today as part of this presentation are my own personal experience and do not reflect or represent the official policy position or recommendation of KPMG Australia, Engineers Australia, or Risk Engineering Society. Obviously, they don't have just have a general nature and should not be used for any decision making before or without any further assessment. And an additional note, you see my email there, but I'm also on LinkedIn and definitely happy to be connected and support you in your journey within the risk management and contingency management. With that brief introduction, I would like to take you through some of the basics. As I said, they're also in other references as well, but it's important to just have a better understanding of the concept before we jump into the case study. When you look at the ISO 31000, 2018, which is the latest revision of a standard, you see there's in terms of the risk management, the standard is putting them based on the framework, which is the circle from designing, implementing, evaluation, improvement, integration. We do have the principles, which is going around the value creation and protecting the value for the organization. And the last but not the least is the process of risk management. And I'm sure you have done your training on the risk management. If you haven't done, I strongly recommend that you go back to the risk management first, do that subject, do that topic before you discuss the contingency, because it's quite fundamentally related. So within the risk management process, there is a step of, or there's a box of risk assessment you see in the middle, which is consists of risk identification. In other words, we identify the risk, we do the risk analysis, and we evaluate. In other words, we say which risk needs to be done properly. In terms of risk analysis, which is now related to the QRA, the risk analysis is the step that will help us to better understand how significant the risk is. It might be through the likelihood of the risk, it might be through the consequence, or both. It might be exposure, but the risk analysis overall is a step that is helping us to better understand the different dimensions of the risk. And generally, there are two approaches. One is a qualitative risk analysis, and the other one is a quantitative risk analysis. As is obvious from the name, is that when you're assessing or when you're analyzing the risk qualitatively, generally you don't have numbers. You're just referring, you're describing the risk. Risk is huge. Risk is the consequence is massive. It's unlikely. It's that sort of description. And even if using some of the numbers is not real numbers, they just they don't represent any some sort of value to the risk analysis. On the other side, when you're dealing with the major projects and when you're taking to the serious level, the risk analysis, the recommendation is that it would be good to have a quantitative. And quantitative risk analysis, or QRA, is putting some numbers. It's putting some. It might be. It's a quantitatively trying to do the risk analysis by bringing some numbers, values, likelihood, probabilities, and so on into the picture. I usually ask what's the best reference for risk assessment, and to me, I think in my experience, the ISO 31010, which just released last year, is the risk management techniques. And although you can see the table, actually there's a wide range of tools and techniques available. There are others, but I think if I want to recommend one initial document that can give you a good understanding of methodologies and techniques and tools initially, I think 31010 is one of the best documents. The case study that today we are having a conversation is related to one of the methodologies, which is the Monte Carlo simulation, or MCS. What the MCS is, and as I said earlier, we are not trying to, we don't get into a lot of details in terms of the concept, but I'm just sharing overall process and some of the key elements of the modeling or the methodology or technique before I get into the case study. I think if you're interested in the MCS methodology or some other tools in terms of the determination of contingency, I think it's one of the sessions that is talking about the cost contingency determination or the risk management and contingency. Is one of those sessions, or both of them will provide you a better understanding of the methodology and the steps and the inputs, the key elements of the modeling and the outputs. So please refer to them. But for the purpose of today, generally, if you haven't used MCS before, this is the methodology that usually involves taking some sort of random sample values from inputs, doing some calculation and getting the result by having a range of distributions. And it does it, the methodology or technique does it through a number of iterations. Like if you look at the this here, the process here, MCS model in the middle. So the inputs there from, or the key elements of the model is starting from the left, and it's including the variables, some of the assumptions that you have, like the volume is not clear, how many people, how many crews you're using. It might be 2, it might be 5. These are all the variables that you do have. Then the second element of it is that there is an inherent and contingent risk. And as I said, if you haven't done the training for definitions of inherent and contingent, again, I recommend that you get back to those risk definitions and contingencies before trying to get into the modeling. Excuse me. And last but not the least is related to the correlations. And correlations is the interdependencies and relationships between variables, inherent risk, contingent risk. It might be positive or negative. It's some sort of trying to explain the dependency. Sometimes one variable is depending on the other one. Like, for example, the design, generally when we put the cost estimate of a project, design is the percentage of the direct cost. If the direct cost goes up, we expect that the cost of the design should go up as well. So we need to put we need to link them together. We need to correlate them together. And that's what the correlation is. With all those inputs in, you develop a model, and we are not going to explaining the model, how the model works for this purpose of today's session, but this is the model that it goes through a number of iterations, like 5,000, 10,000 different scenarios, making different assumptions for any of those elements, run the model, And then eventually it will generate some sort of output, which might be based on the cost, it might be based on the schedule, but it's some sort of S-curve that will give you a range of possibilities. And then in addition to the possibilities, it will generate some sort of likelihood that the variable or the output that you're looking or you're monitoring, it should be less or equivalent to that number. In other words, so for example, if you're using the P80, which is the probability of 80% confidence level, or the 80% confidence level, there is a 80% chance that you will finish the project before that or up to that date. It's that sort of feeling, or exactly the same for the dollars, that it will give you some sort of presentation of possibilities, and it will make the decision making easier. Some of the basics in terms of the 3-point estimate, like again, if you haven't done them, there's a statistics. I'm referring to the risk contingency guideline, which is I think is available as one of the references to your course. If it's not, please discuss with your lecturer, and it should be. And I'm also happy to provide a copy for the education purposes. Some of the statistics and some of the ranges that we do need them for modeling. But for the purpose of today, let's get into our case study. Just see how does it work in practice. So this case study is specifically referring to the cost risk analysis, which is one of the methodologies on the QRA. As I said earlier, the QRA is covering a wide range of methodologies and tools. It's some sort of quantitative risk assessment or risk analysis or methodology that can help you to better understand the risk quantitatively. It's sitting on the quantitative risk analysis. One of those techniques or methodologies is cost risk analysis, or CRA. There are some assumptions or there are some key elements of the cost risk analysis. One is making sure that the most likely assumptions for the base estimate and base schedule is being used. There's a top-down or bottom-up approach. Depending on the requirements, you need to say which one is the more appropriate method of using that. Having the inherent and contingent risk assessment is important. So if, again, referring to the definition of inherent and contingent, if you haven't done that sort of thing, I recommend that you read that material first before trying to get the modeling. Again, range of the uncertainty range, having a wide range, especially for the worst case scenarios, trying to push it to the edge, understanding if it goes wrong, how wrong it can be, and then trying to see the possible worst case scenarios. And a couple of other ones like the probability density function, optimism bias or cognitive biases, understanding them, trying to mitigate them as much as you can, trying to address them in the modeling perspective. Again, that's quite important. Earlier, I mentioned the correlation, which might be through the direct correlation. It might be an inherent risk or contingent risk or a combination of them. It's quite important. And the last but not the least is the schedule contingency and its integration into the cost risk model. So these are the key elements of the cost risk analysis. But how does it work in this case study, which from a process perspective, we referred to risk contingency guideline? It's quite again, when it comes to the subject of contingency management, I think there are a number of good reference books or references or recommended practices globally. But the risk contingency guideline is a document that RES and Engineers Australia started to develop from 2013. The first edition was released in 2016, and the second edition, which is the one that I'm referring to, released in 2019. So there's definitely, it's a very, very good document as a starting point, because it does cover the contingency across the whole cycle, which is from determination, allocation, and control. So it's quite good from that perspective, but also it's important that it does cover it for the schedule and the cost element at the same time. And also it does cover some other elements of the contingency, like contingency management. For example, how does it work if you have a portfolio? right? So it's a very good document. If I strongly recommend that you have a look in this reference book if you're interested in the subject of contingency. Okay, in terms of getting back to our case study, the cost risk analysis process, generally there's a very common process or recommended process that we follow. The easiest way to explain it is actually the process does have two starting points. One is from here, from the left, and from the left is developing the base. You see the top and estimating software and the base estimate. So that's one element of the work, which you need to develop a base estimate. At the same time, you need to develop the base schedule. And these are the scenarios that in the most likely scenario, or most credible scenario, how long does it take? How much does it cost? And these are the assumptions that they're most likely assumptions. And we are using in industry, we use different software for estimation, and we do have a different software for the scheduling. But eventually, what it comes into the left side is actually developing the base estimate and schedule. So that's one element. The other one that you need to start from right now is that having the workshop. So starting to develop some pre-workshop sessions, having the risk workshops, understanding the areas of concern, and as I said, the inherent risk, contingent risk, understanding the schedule risk, and developing that. So this is the whole process of that. So it's identification and sometimes assessment of the risk as well in terms of individually. And then when you get the right in place and you have the left in place, then it's the time that you put everything into the middle. And this middle one is the one that previously we had is developing a model by using a simulation, Monte Carlo simulation, MCS, that helping to and when you run it through a number of iterations, like 10,000 times, it will develop the cost and the time of the project for 10,000 different scenarios. And then the software will go through them, and then it will generate them. Like, for example, you said, in how many of those scenarios, the cost of the project is less than 200 million, and it will calculate the probability. Then it will goes again and said, in how many of those iterations, like out of 10,000 scenarios, how many of them the project could finish before this date? And that's how the software does it. I mean, if you want to look at some of the inputs, this is the example that we had is a software that we use for that project specifically. And then some of the this how it look like the cost risk model. We do have the base estimate. We do have the inherent risk. We do have a section for contingent risk that we define. This is for this example, we use Excel, but there are a number of other platforms that also we use it. And then the correlation is a section that we define the relationships between them. So this is how it look like. So from a schedule perspective, we do have a software. Generally, it's not Excel, because you can't do it in Excel. There's a number of platforms, good platforms that we use. From a cost risk modeling, the Excel, most of them they're Excel based. However, over the last few years, a couple of platforms emerged that they don't need Excel. They just run it as on their own platform, but there's still the Excel add-on in Excel. It still is the most common tool for doing the simulation. And then you get the result. So you just develop the model, you get the inputs, you put them into the model, and you get the result based on some sort of S-curve and S-curves and histograms and tornado, which will give some sort of ranking of the high priorities. So this is just give you a quick example of application of QRA. And I think just recapping again, I'm not going through them again, but just make sure that when you're developing the cost risk analysis, it's quite important to prepare the inputs properly. So if I want to suggest for any cost risk analysis, there are three elements that you need to make sure that you cover them. So the base definitely you need to make sure that the base, actually their base, in other words, they're most likely, if the people putting some allowance or fat or contingency or whatever you want to call it into the base, then by the time you do the risk modeling, you're putting another layer of contingency on top of it. So it's a contingency on top of contingency, and it's not giving you the right answer. Making sure that you do have the proper risk workshops and proper risk assessments, and making sure that you do have inherent and contingent risk at the same time, and do modeling together, because if you don't, then you're not getting the optimum. Because eventually, remember that you need to remember that the purpose of the modeling is not just get a number out of it or get a duration. It's actually, you can make any assumption that you like, but it should be reasonable. It should be optimum contingency, because if you put too much, if you ask for too much contingency and you're a contractor, you may not win the job, so you lose the opportunity. On the other side, if you don't put enough money, you win it, and then you cannot deliver it because it's quite a competitive environment. So the key question and challenging part is that how much is enough? How much is that we can win the job and deliver the job from a contractor's perspective, and also from a government perspective, is that if they plan for too big and they put too much contingency, because the budget is limited, the project may not fly, it may not proceed at all. So from a government perspective, it's important that how much is enough that we can push the project going through, but at the same time, we can deliver it, and the industry can deliver it and produce value for the government. And I think, yeah, that's about it for today's session, which was the quantitative one. As I said earlier, please keep in touch. This is just a very short presentation to give you a little bit more and support you to discuss and review the full material in a full content. If you have any questions, please keep in touch with your lecturer or myself. And as I said earlier, if you would like to be connected through LinkedIn, and I'm definitely happy to support you further. I think till now, till the next time, thanks again, and good luck. Bye.